Hello, myself Tarpan Suja. I am computer programmer. This video series is about computer algebra. In this video we will discuss what is an equation, how to solve equation and inequality in equations. Let's start the discussion with the topic what is an equation. An equation says that two things are equal. It is denoted by the equal sign. Or an equation is a mathematical statement that asserts the inequality or equality of two expressions with one or more unknown variables. One side inequality means one side is either greater than, less than, or greater than equal to from other side. One side is known as left hand side and other side is right hand side. For example, z minus 5 less than equal to 4z when we put the value of z is equal to 1. Means to say z is equal to 1 satisfying this equation. What is a solution? A solution to an equation or inequality is any number, that is z is equal to 1. When plugged into the equation, when we plug the value of z1 is equal to 1 into this equation, will satisfy the equation or inequality. That means z is equal to 1 is a solution, because when we put the value of z is equal to 1 into the equation, it satisfies the equation. We have three types of solution sets. A system of linear equation can have no solution, a unique solution, or infinitely many solutions. Example, find the solution of the following equation. Suppose we have a equation x square minus 9 left hand side is equal to 0 right hand side. If we put the value of x 3, then what will happen? 3 square is equal to 9, 9 minus 9 is equal to 0. Minus 3 square is equal to 9 minus 9 is equal to 0. That means plus minus 3 is satisfying the equation. Let's do all the magic work using Sympy. First step, import all the function from Sympy. Create the 5 symbols or 3 symbols. Also we turn on the pretty printing by calling the init printing methods. Let's start the work using Sympy. Suppose our equation EQ. We define the equation by calling EQ method. X double stack 2 minus 9 left hand side, pass the right hand side 0. Okay, expression. So this is our equation, x square minus 9 is equal to 0. Now we want to find the solution using Sympy. A solution to an equation or inequality is any number that when we plugged into the equation or inequality will satisfy the equation. So after putting the value of x3, so solve equation EXPR, we Sympy provide us a very useful method solve, which takes two arguments, or optionally we can pass the second argument. The first argument, which is mandatory, is the expression. Shift enter and it will return us the value of x, which will satisfy the equation. We can pass the second argument, the variable x, for which we will put the value, and this solution set will satisfy the equation. So this equation have two solutions, one is minus 3 and second is 3. Let's check now. Return value true, that means left hand, this value minus 3 and 3. So let's check now whether it is right or wrong. To do that, we put the value of x into the equation by calling substitute method. Substitute x value 3, shift enter, true. That means it is a true value. Let's check now putting some another value. Suppose we put expr dot substitute x value 4, false. That means 4 doesn't satisfy this equation. 16 minus 9 is equal to 15, 15 is equal to 0, wrong, false. So we can check the equation by putting value, by calling substitute method, by substituting the value of the variable in the equation, whether it is true or not, whether it is a solution, whether it is satisfying the equation or not. Next, Next thing we have, suppose a equation 1 is equal to eq x plus y left hand side and 5 is right hand side. When you execute the code, x plus y is equal to 5. So in the right hand side we have 5, in the left hand side we have x plus y, two variable. This equation have two variable x and y. eq2 is equal to eq x double strike 2 plus y double strike 2 comma 17 and print x square plus y square is equal to 17. Now check where by calling solve method for the solution to these two equations, eq 1 comma eq2 comma the variables x comma y, shift enter. So what we are doing here, we are calling the solve method for these two equations, equation 1 and equation 2, and getting a solution set which satisfies the both the equation. For example, when you put the value of 1 for x and value of y for value of 4 to the value of y, 1 plus 4 is equal to 5, and in equation 2, 1 square plus 4 square 16 plus 1 is equal to 17. That means it is satisfying both the equation. We have two solutions here, 1 comma 4 and 4 comma 1. So by calling solve method, we can check the common solution for two or more equations. Next thing is, let's cross check the equation with solution set. Suppose eq1 dot substitute eq1 dot substitute x comma 1, shift enter, and the value of substitute y comma 4, shift enter is true. That means equation 1 is satisfying with the value of x is equal to 1 and y is equal to 4. Next check it with the equation number 2. This is also true. That means 1 and 4, value of x is equal to 1 and value of y is equal to 4, satisfying both the equation 1 and equation 2. And now check the value of 4 1. For that, equation 1, x value is equal to 4, x value is equal to 4 and y value is equal to 1, and this is also true. Check it for equation 2. Equation 2, this is true. So by calling solve method, we can check a common solution for equation 1 and equation 2 for the value of x and y. Now another thing we see, we will do u. Suppose we have equation u, and in that equation we have 3 into y plus 1 comma 0 u 3y plus 3 is equal to 0, v is equal to eq 4 into y minus 5 comma 0 v, shift enter, 4y minus 5 is equal to 0. Now check and get the solution set for u and v. For that we will call u comma v comma y, shift enter. Return the empty set, no common solution. That means if equations have no common solution for them, we will get an empty set. Suppose we have an equation u is equal to this and right hand side is equal to 27 and equation v, shift enter, equation v, shift enter, 4y minus 5 is equal to 27. We have a one solution, that is value of 8. How to get that value? Solve u comma v comma y, shift enter, value of 8. If we put the value of 8 in both the equation, for example in first equation u, 8 into 3 is 24 plus 3 27. 8 into 4 is 32 minus 5 is equal to 27. So this is our solution. Let's check it in Sympy package, using Sympy package. So for that we substitute value of y in u is equal to 8 and true v is dot substitute value of y comma 8, shift enter. Sympy also provide us a method for doing the same thing, that means cross checking whether the solution is right or wrong. It provides us a method that is check solution. Check solution in which takes two parameters. First is expression and second is the value of variables. So value of variable is y and 8. Check solution true. That means for expression u, value of y if put 8 is right. So this is another method. You can substitute the value of variables into the expressions to check whether it is a solution or not, into the equation whether it is a solution or not. And Sympy also provides us a method check solution in which takes two parameter and returns a boolean value whether a solution is right or wrong. Next thing is next thing is inequality. What is inequality? We have seen that one side is either greater than left hand equations, one side yani left hand side of equation is either greater than, less than, greater than equal to or less than equal to from another side, that is right hand side. That is inequality, and we solve inequality in Sympy. Sympy provides us many methods to do that. Let's do it. Expression is equal to z minus 5 which is less than equal to 4 into z expression. Z minus 5 is less than equal to 4 into z. Let's check by substituting the value of z. Expression dot substitute value of z, suppose put 1, shift enter, true, means 1 is a value which satisfies the equation, which satisfies the inequality. So this is an inequality problem. Now next thing, expression. Suppose we have an expression that is minus x plus 4 less than 0 expression. We have an expression 4 minus x less than 0. We want to check this inequality equation by calling the method solve underscore poly inequality provided by the Sympy package. For that, we apart the two sides, that is the left hand sides and right hand side of this expression, poly expression dot LHS, that is left hand side, comma x, and print p. So this is our first polynomial, that is the left hand side. Let's check the inequality. Solve underscore poly underscore inequality p comma less than sign. Less than, we have the equation minus x plus 4 left hand side, and less than 0. So solve poly inequality. It returns us a set of 4 comma infinity, means to say if we put the value of 5 minus 5 plus v, which is less than 0, to infinity, that means the any value from 5 to infinity is our solution. For rational inequality, we know that what are rational expressions. Rational expressions are fractions, a rational expression in which the numerator and denominator are both polynomial. For that, Sympy provides us rational inequality method. Like solve poly inequality, we also have a solve rational inequality method in Sympy. Let's take an example. Symbol x. Expression is equal to x plus 1 divided by x plus 2 greater than 0 expression. Module object is not callable. Let's check it. Module object x is okay. So this is our equation. Take the left hand side of the equation. LHS is equal to LHS left hand side, that is x plus 1, x plus 2. Now take the operator and also the numerator and denominator of the expression. To do that, we have create two variable, numerator comma denominator is equal to LHS dot as underscore numerator underscore denominator, print them, shift enter, x plus 1 and x plus 2. Now we will get the convert them, this numerator and denominator, into two polynomials, p1 poly numerator comma x p1, and second polynomial, that is p2 and denominator, shift enter, x plus 2, and now get the relational operator between them, inequality operator, that is greater than equal to 0. For that, we will do relation rel, a variable, is equal to expression dot rel underscore op and print rel, shift enter, it is greater than sign. Now we solve the rational inequality. Solve underscore rational inequalities, EQUAL, pass p1 comma p2 numerator and denominator of the rational expression and the operator between them. Shift enter to run the code. Okay, can't unpack non-iterable. Okay, we miss some bracket here, so this way. Shift enter, and this is our set minus infinity up to minus 2 and -1 to infinity. We get a set, interval set, which satisfy this rational inequality. So solve rational inequality and solve Pauli inequalities are methods in the provided by the Sympy package to check the inequalities of the equations. Let's do another example of univariate data, that is a expression which contains only one variable. For that we have solve univariate inequality and x to greater than equal to 4 comma x comma relational is equal to false. Shift enter. It returns us the set which satisfied this expression. Take another example. If we do not pass the relational is equal to false, then we will get x is greater than or equal to 2 here. Means to that we are including open interval, we are including 2 also, and x is less than infinity, or x is less than equal to -1 and x is greater than minus infinity. Though this gives us the complete relation set, and this only provide the values. So if you want to see in this form, then you need not to pass the relational is equal to false. Let's take one more example of univariate inequality. Expression is equal to sin x minus 0.6 greater than 0 . Solve Pauli univariate inequality. Expression comma x comma relational is equal to false, and this is our result. So in this video we have seen what is an equation. This is very important video. What is an equation, what is inequality, what is solution, and we all have done the practically using Sympy package. So for now, bye and thanks for watching this video. We will meet soon into the next video. Bye.